Welcome to the Explainer. You see them on the highway every single day, right? But I guarantee most of us completely misunderstand them. Yep, we're talking about car spoilers. You look at a spoiler and probably immediately think of screaming race cars or just flashy, aesthetic upgrades. But actually, hidden behind that sporty exterior is some incredibly practical, money-saving science. So today, we're totally bypassing the aesthetics. We're going to uncover how spoilers actively manipulate the air around your vehicle to drastically reduce your fuel consumption.
Do spoilers just make cars look fast? Okay, let's dive right into this. It's a super common myth that commercial vehicles only slap on spoilers to look cool, providing zero real aerodynamic advantage unless you're flying around a track at 200 miles per hour. But the research? It tells a completely different story. Whether you're driving a daily commuter sedan, a bulky SUV, or maybe you're towing a camper trailer on a family vacation, the spoiler actually plays an absolutely crucial role in boosting your vehicle's fuel efficiency. And to understand exactly how it saves you cash at the pump, well, we first need to understand the invisible wall your car hits every single time you hit the gas.
Aerodynamic drag. It's the resistance force opposing a vehicle's forward motion through the air, heavily impacting fuel consumption. That invisible wall? That's aerodynamic drag. Think of drag as the invisible enemy of your fuel economy. As your car moves forward, the air essentially pushes back. The aerodynamic force acting on a moving vehicle is created by the vertical and tangential contact of the air against every single point of your car's surface. Because of this resistance, your engine literally has to work significantly harder, burning more fuel just to shove the vehicle through the atmosphere. It's kind of like walking through waist-deep water. If we can lower that drag, we make the engine's job easier, and boom, we immediately save fuel.
To see exactly how a spoiler fights that drag, let's think about how air flows over the curved roof of a standard car without one. As the air drops off the back, it creates this tumbling, turbulent wake, a low-pressure zone. This low-pressure zone basically acts like a giant vacuum, literally pulling the car backward. Now, contrast that with a spoiler attached. The main purpose of the spoiler is exactly what the name implies. It spoils that unwanted smooth airflow right at the back. By kicking the air up and away, it shrinks that low-pressure vacuum zone behind the vehicle. Less vacuum pulling you back means less turbulence and significantly lower drag.
65%. Now, if you're sitting there wondering if this really matters for just a regular commute, consider this massive figure. According to the research, when your car hits a highway speed of 110 kilometers per hour, a staggering 65% of the power generated by your fuel is used solely to overcome aerodynamic drag. Literally more than half of the gas you're burning at highway speeds is just to fight the air. So reducing that drag even by a tiny fraction of a percent, that can have a massive impact on your wallet over the lifetime of a vehicle.
The 1930s Kammback principle, truncating the tail of a car to maintain smooth airflow and eliminate turbulence. The whole foundation for this airflow manipulation actually goes way back to the 1930s, thanks to a German aerodynamicist named Wunibald Kamm. Researchers knew that the absolute ideal shape to slice through the air with zero drag is a teardrop, a rounded nose with a very long tapered tail. But obviously, trying to parallel park a giant teardrop isn't exactly practical for a grocery run. Kamm proved that if you abruptly cut off or truncate the tail of the car at a specific vertical angle, the air actually acts as if that long tail is still there. This is the Kammback principle. The turbulent wake forms perfectly behind the vertical surface, preventing the air from separating too early and keeping the overall drag incredibly low. Modern spoilers build directly on this idea by artificially managing exactly where that air separates.
We can actually see this in action using computational fluid dynamics. Notice the velocity contours mapped out. The blue and green colors show the speed and pressure of the air. With a flat, 0-degree spoiler on the left, there's a relatively massive blue area trailing behind the car. That's a huge zone of turbulent, recirculating air creating a ton of drag. But look at the right side. With a spoiler pitched at an optimal 30-degree angle, notice how that dark blue zone behind the car has physically shrunk. The 30-degree spoiler is actively reshaping the air, reducing the size of that drag-inducing wake. It's a real game changer.
Without spoilers, larger turbulence recirculation zone and higher drag, versus with spoiler, redirected airflow, smaller recirculation zone, and negative lift. Let's break down that contrast clearly. Without a spoiler, the air just dumps off the back, creating a large, tumbling, turbulent recirculation zone. That equals high drag and high fuel consumption. Plus, airflow over the windshield and rear window can actually create lift, making the car's rear end feel light, jumpy, and kinda unstable at high speeds. But with a properly angled spoiler, the airflow is purposefully redirected.
You get a smaller recirculation zone, and crucially, the spoiler creates higher air pressure right in front of it. This generates negative lift, or downforce. This pushes the tires firmly and steadily right into the road, giving the car much greater stability without punishing the engine.
Let's look at some concrete experimental data. We have an SUV model showing a 5.72% reduction in drag coefficient with an Albatross-type spoiler. Then, a sedan with a NACA 2412 aerofoil, seeing a 7.8% drop in power consumption and 8.5% better fuel economy. Researchers tested a 1/32nd scale model of an SUV, which, let's face it, is a notoriously boxy, high-drag vehicle. By adding that Albatross-type spoiler, they slashed the vehicle's total drag coefficient by nearly 6%. Then, in a totally separate study on a standard sedan, researchers added a NACA 2412 aerofoil spoiler. The result? A 7.8% drop in engine power consumption, directly resulting in an 8.5% improvement in fuel economy. Just imagine getting 8.5% more miles out of every single tank of gas, simply because a piece of engineered plastic on your trunk is managing the airflow better. No way, right? But it works.
13.5%. So the absolute crucial point here is that spoilers yield incredibly tangible results when it comes to fuel reduction. But actually, it gets even better. Look at this astonishing figure. This massive fuel savings wasn't found on a sleek sedan. It was discovered during road tests of a passenger car towing a large, boxy caravan. Pulling a caravan normally increases a car's frontal area so much that fuel consumption can jump by a terrifying 117%. But researchers found that by mounting a prototype roof spoiler at a 30-degree angle on the back of the towing car, they could deflect the air right over the top of the bulky caravan. This single modification dropped the total fuel consumption by a staggering 13.5%.
And we know these aren't just, theoretical computer models. Looking at the rigorous road test parameters mapped out, they tracked the route, accounted for a crosswind blowing at 2 to 3 meters per second, and factored in road slopes, the whole shebang. The real-world results were just undeniable. To put that 13.5% savings into perspective, on an average 3,000-kilometer recreational trip, using that 30-degree roof spoiler would save the driver over €73 in fuel costs alone. Not only that, but by burning less fuel, the car emitted 159 fewer kilograms of CO2 into the atmosphere over that single trip. So let's look at the multifaceted benefits of spoilers. Increased fuel economy, enhanced high-speed stability, improved road traction, better braking, and reduced CO2 emissions. When we look at all the evidence combined, we see that spoilers are far, far more than just decorative trim. They offer a complete package of benefits. By slicing through aerodynamic drag, they significantly increase fuel economy and gas mileage, directly saving you money. By generating downforce and neutralizing lift, they enhance high-speed stability, keeping the car firmly planted. This improved grip gives you better road traction, safer cornering, and, even better braking performance. And as a really wonderful byproduct of the engine doing a lot less work, your vehicle naturally produces fewer CO2 emissions, making it a surprisingly environmentally friendly modification.
Knowing the hidden science of airflow, will you look for a spoiler on your next daily commuter car? It is genuinely fascinating how manipulating invisible air currents can lead to such physical, measurable benefits in our daily lives. I mean, from the 1930s aerodynamic pioneers to modern computational fluid dynamics, the science is absolutely clear. The spoiler is an unsung hero of automotive fuel efficiency. So I'll leave you with this provocative thought. Knowing the hidden science of airflow, the next time you're at a dealership looking for a sensible, economical, daily commuter, will you be checking the back trunk to see if it comes with a spoiler? Thank you so much for joining me on this explainer, and I hope you never look at a car the same way again.